Hello everyone, welcome to Chemazon-Complete Chemistry. In today's video, we are going to solve some questions of the Part C of the same CSIR NET June 2023 chemistry paper. So these are some of the questions that we are going to solve in this video. Let us solve the first question. So what is given to us is pH, C triple bond C, Me. This is which functional group? Carbon-carbon triple bond is alkyne. And we are reacting it with ruthenium dioxide that is used as a catalyst, and we have sodium iodate NaIO4, and we have to identify the product. So what will happen is, first step is ruthenium oxide. It reacts with NaIO4. It will undergo oxidation and it will form what? It will form ruthenium tetroxide. This is called as ruthenium tetroxide. Okay, what is the structure of ruthenium tetroxide? It is tetrahedral. It is attached to 4 oxygen atoms via double bond. Now this will react with alkyne, double bond O, double bond O, double bond O, double bond O. So here if you see, what will be the oxidation state of ruthenium here? One oxygen is -2. There are 4 such oxygens. So here oxidation state is +8. Okay, so now what will happen? This will react. Okay, how it will react? This will attack here, and this will attack this oxygen, and the pi electrons of ruthenium will be donated to the ruthenium atom. So now what we will get is pH triple bond will now become single bond Me. This has formed bond with oxygen, ruthenium, oxygen, ruthenium, double bond O, double bond O. Now if you see, what is the oxidation state of ruthenium here? This is -2, -2, -1, -1. So this has got reduced from +8 to +6. That is, this is undergoing reduction, and the alkyne or carbon-carbon triple bond is getting oxidized. Now what is the last step? This will form a carbon-carbon, carbon-oxygen double bond, and this bond will also break like this. Okay, so what do we get is we get carbon-carbon single bond will now become what? It becomes carbon-carbon double bond like this. Okay, here also carbon-carbon double bond and methyl. And what is left out? Now there 2 more electrons are added to ruthenium. So it becomes what? It becomes, its oxidation state reduces further from +6 to +4. This is -2, -2. This has become +4, RuO2. Now this RuO2 or ruthenium dioxide can again undergo oxidation, become RuO4, and it can react with other alkyne molecule, and the reaction will go on. Okay, so what is the correct answer? This is a final product. This is what this we can call it as 1,2-dione. One means ketone. Di means there are 2 ketone groups. That is why it is called as 1,2-dione. So what is the correct answer? Correct answer is option 4. Now let us see the next one. Among the 4 species, the number of species having seesaw shape. So for finding out the hybridization, first we must know the formula to find out the hybridization or steric number. What is the formula? Half into number of valence electron of the central atom. What is central atom? It is the one that is less in number, that is central atom, plus hydrogen, plus number of halogens, plus if there is any negative charge, because when we add negative charge we get minus sign. When we add electrons we get minus sign. Minus positive. Okay, why minus positive? Because when we remove electrons we get a positive charge. So this was the formula for hybridization. How to calculate number of lone pairs? Number of lone pairs is steric number, that is the answer from this formula, minus the side atom. Okay, now let us see the examples. First is SF4. This will be half. Sulfur belongs to group 16, so 6 valence electrons plus 0 hydrogen plus how many halogen? X is what here? It is fluorine, chlorine, bromine or iodine. So there are 4 fluorine atoms, so plus 4. 10 divided by 2 is 5. So the hybridization is sp3d. How many lone pair? 5 minus side atom are 4. So this will be 1. Okay, so what will be the geometry? For steric number 5, the geometry is trigonal bipyramidal. Okay, trigonal bipyramidal like this. Now you have to remember the trigonal part hybridization is sp2 and the axial part hybridization is pd. And you have to remember that lone pair is what? It is percentage S loving. Okay, so in trigonal bipyramidal geometry, the lone pair is occupied by the trigonal part. That is, we will draw lone pair at the triangular part first. Okay, trigonal part first, because here if you see there is 33% S character. Here there is no S orbital. This is 0% S character. So since this is percentage S loving, it will occupy the trigonal part. But if you talk about the octahedral geometry, here the lone pair occupies the axial position. Why? Because if here it is present in plane, it will cause electronic repulsion. So it occupies the axial position. Okay, so 5 and 1 lone pair. So what will be the structure of SF4? S, 1 lone pair at the trigonal part, and then there are 4 fluorine atoms like this. Okay, what is the seesaw? Seesaw is like this, right? This is seesaw shape. So this looks like a seesaw. So this is having a seesaw shape. So this is one of the correct answers. Next we have ClO4 minus. This will be half. Here central atom is Cl. So 7 valence electron. It belongs to group 17 plus 1 negative charge. 7 plus 1, 8 divided by 2 is 4. So hybridization is sp3. Okay, it will be tetrahedral. So this is incorrect. Third one, FClO3. Here the chlorine is the central atom. 7 plus 1 halogen. So 8 divided by 2, 4. This is also sp3. This will also be tetrahedral. So this is incorrect. And last one, if you see, IF4 plus, this will be half into iodine has 7 valence electron plus 4 fluorine atoms. Positive charge means minus 1. 7 plus 4, 11. 11 minus 1, 10. 10 divided by 2 is 5. And how many lone pairs are present? 5 minus, there are 4 side atoms. So this will also have the geometry. How will the geometry of IF4 look like? I having 1 lone pair and the remaining 4 fluorine atoms. So this is also what? This is also seesaw. So fourth is also seesaw. So there are 2 species which are seesaw. So the correct answer will be 2. Okay, remember this option is correct. You don't have to mark this. These are what? These are the options. Okay, read the question carefully. These are the options. And these are the answers. So second, that is option 1 will be the correct answer. Okay, let us see the next one. Identify P and Q in the following reaction sequence. So this is the reaction of metal carbonyls. Okay, what is the first step? First step is MnCO5 minus, this will react with C3H5Cl. What is C3H5Cl? It is allyl chloride, that is CH2 double bond CH, CH2 Cl. You can see this is C3, 3 carbon and 4 plus 2 plus 2, 1 plus 1, 2 plus 2, 4 plus 1, 5 hydrogen. So this is C3H5Cl. So first step is substitution reaction. This will attack here and Cl will go away as a living group. What we will get? We will get CO5 will remain as it is. This will be manganese. Now what we want? We want a stable species. And which are the stable species? Stable species are ones that have 18 electron in their, that is total valence electron is 18. So carbonyl gives 2 electrons. So there are 5 carbonyls. So 5 into 2, 10. Plus manganese, what is the electronic configuration? Manganese, it is Ar 3d5 4s2. So there are 5 plus 2, 7 electrons. So 5 to the 10, 10 plus 1, 7, 17. Plus how much will give us 18? 1. So the hapticity here it is 1. What will be the structure of this? Structure of this will be Mn CO 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 CO, and here this will be CH2 CH double bond CH2. That is, it is attached to only one carbon. That is what is the meaning of hapticity. Now what is the next step? When we heat, there will be loss of one CO. Okay, one CO will be lost, and the hapticity will now change. Now if you see MnCO4, so 4 CO means 4 to the 8, 8 plus 7 is 15. So for 18 we need 3 more electrons. So this will be eta 3 C3H5. The total electrons are what? It is same as the hapticity. So now it will be 3 hapticity. So what will be the structure? CH2 CH CH2. We draw like this. This means all the 3 atoms are connected to manganese. That is, it is 3 hapticity. Okay, and then there are 4 CO. Okay, so this is what this is P and this is Q. So which is the correct answer? Eta 1 C3H5 MnCO5. This is the correct answer. And then eta 3 C3H5 MnCO4. Let us see the next question. Consider the cell. So the cell representation is given. Complete cell reaction is given. Okay, what is given? Molality of HCl is given, that is B. So let us first write down the half cell reaction to find out the value of N, that is the total electrons. So at the anode, oxidation take place. So anode, you can see it is H2 on the left hand side. Okay, here you can see H2. So hydrogen is getting oxidized. That is loss of electrons. So 1 mole of H2 will give 2 H plus ions plus 2 electrons. This is oxidation. A loss of electrons. Then at the cathode, what takes place? Reduction. This will be 2 AgCl plus 2 electrons. This will become 2 Ag solid plus 2 Cl minus plus 2 Cl minus aqueous. Add. You can see there are 2 electrons involved, so N is equal to 2, and the overall cell reaction will be 1H2 plus 2 AgCl solid. It gives 2H plus aqueous plus 2 Cl minus aqueous plus 2 Ag solid. Okay, this 2 H plus aqueous and 2 Cl minus aqueous only they have written as 2 HCl aqueous. Okay, now we have to find out what is the formula for Nernst equation. E cell is equal to E0 cell minus, okay, here it is ln, so we will write nRT. Okay, there will be no 2.303, it will be RT upon NF ln Q. Okay, this is a formula. Q is the reaction quotient that we have to find out. Okay, and then N we have found out it is 2. Okay, Q will be, it is reaction quotient, concentration of products divided by concentration of reactants. Okay, so product what we have 2 Cl minus 2 H plus. So this will be H plus raised to 2, Cl minus raised to 2. Okay, solid are inactive species, so we will not consider them. And in the denominator we have pressure of H2 gas. Okay, they have given it is a standard pressure, so it is 1 atmosphere. So we can ignore this. What is the concentration? We know the formula A is equal to m gamma. Okay, A is the activity. Okay, here instead of concentration, it should be activity. Activity is the most appropriate term. Okay, generally we consider gamma is equal to 1, that is the activity coefficient is equal to 1. That is why we write activity as concentration. Okay, here they've given the activity coefficient, so we will write in terms of activity. Okay, A is equal to m gamma. What is molality? They've given B. So B gamma raised to 2. This will be B gamma raised to 2. Okay, this will be how much? This will be B gamma raised to 4. Okay, now we can substitute in this formula. I can erase this. Okay, so now we can substitute E cell, that is cell potential, is equal to E0 cell, they've written as like this. E cell they've written as E minus RT by NF. N is 2. Okay, Ln, this is B gamma raised to 4. Okay, we know this logarithmic law. Ln of A raised to M is M ln A. Okay, this we bring it down. So this will be E0 minus 4 into RT by 2F into ln. This they have written as gamma B or B gamma, both the same. Okay, now 2 ones are 2 twos are. So this will be E0 minus 2 RT by F into ln gamma B. So which is the correct answer? 2 RT by F minus 2 RT by F. So the correct answer is option 1. Next one, the number of unpaired electrons in Cp2Fe, Cp2Ni and Cp2Co. Okay, M2, Cp2M, that is what these are. Okay, these are what? These are metallocenes. Okay, we have to find out the unpaired electrons. For that, we must know the energy diagram or orbital energy diagram. This is E2. Okay, this is A1G. This is E1G star. Okay, the energy difference between E2 and A1G is very small as compared to E1G and A1G. This is important. Okay, so for first we will find out for Cp2Fe. And always remember Cp is what? Cp is this. Cyclopentadienyl anion. So the charge of this is -1. Okay, so what will be the first one? Cp2Fe. Oxidation state of Fe will be, this is -1 into 2, -2 plus x is equal to 0. X will be +2. So it is Fe plus 2. Okay, Fe plus 2. How many electrons? It will be 6 electrons. Let us write down for Fe. It is Ar 3d 6 4s2. Now Fe2 plus, so we will remove 2 electrons from 4s. So it is 3d 6. So let us fill the electrons. This is very important. How to fill the electrons? 1, 2, and then we will fill this, because all are approx same energies. Energy difference is very less. You can consider these three as the 3 p orbitals like this. Okay, similar to that. So 3 electrons, then you start pairing. Okay, you will not go here. This is not correct because energy difference is higher. So 1, 2, 3, then you start pairing 4, 5, and 6. So here we have how many unpaired electrons? 0. Next will be Ni. Ni will be Ni2 plus. So this will be Ar 3d8. Okay, now we have to fill 8 electrons. Let us fill again. 1, 2, 3, 4, 5, 6, 7, and 8. So you can see there are how many unpaired electrons? 2. And last one is cobalt 2 plus Ar 3d7. Now we have to fill 7 electrons. Okay, let us fill again. 1, 2, 3, 4, 5, 6 and 7. So there is one unpaired electron. So the correct answer is 0, 2, 1. 0 to 1, our correct answer is option 2. Now this is the next question. This is what from the reagent you can see it is heat. Heat means heat or light is given, and from the options also you can see it is from pericyclic reactions. Okay, so first let us see the product what they have given. Okay, from the product we will try to identify what reactant we want and accordingly we can work. Okay, here we have like this, and here there is a CH2 bridge, methylene bridge, then hydrogen above the plane. Okay, like this. So you can see this part would have come from this anhydride that they've given, right? This is the dienophile. Now what we want is we want a diene. Okay, the molecule given to us is this, but what we want is we want a diene. Okay, we want molecule to be like this, right? So that this is the CH2 bridge. Okay, this if you react with this, you can come to know you will get the correct product like this. You will get this product. Okay, you will get this product. So we want the reactant to be this, but is this the reactant that is given? No. So what is the reactant that is given to us? Reactant that is given to us is benzene. Okay, and then I have like this. Okay, H. So I want a double bond here and a double bond here. Here there are two hydrogens. Okay, this is the initial one. So what I can do, I have to bring this hydrogen over here. Yeah, I have to bring this hydrogen over here. So how will I do the reaction? I will bring this hydrogen here. Okay, this hydrogen electrons will form a pi bond here. That is what we want, right? And then this pi bond will shift here. Okay, so this is what type of shift? This I mark it as 1. This will be 1. So 1, 2, 3, 4 and 5. So this is what? This is 1, 5 sigmatropic shift. Okay, which shift? Hydrogen shift. 1, 5 hydrogen shift. Okay, then what we will get? We will get the desired reactant that we want. Okay, here between 1 and 2, 1, 2, 3, 4, 5. Okay, between 1 and 2 there is double bond, 3 and 4 there is double bond, and 5 there are two hydrogens. One hydrogen was already there, there is one more hydrogen. Okay, so what we did this, and which is this reaction that I showed you earlier. This is which reaction? This is a diene. This is a dienophile. Okay, like this, and this will attack here. So this is, I can say 4 plus 2 cycloaddition or Diels-Alder reaction. Okay, 1, 5 hydrogen shift and cycloaddition. So the correct answer is option 2. Now this question, consider the following reaction scheme and the related statements. So for this we must know the products of this reaction or else you cannot solve this. They've given some hints. BRF. This is undergoing disproportionation. What is the meaning of disproportionation? Same element undergoing oxidation as well as reduction. Okay, Br will only undergo oxidation as well as reduction. Okay, this is Br2 plus we will get BrF3. Okay, so X is what? X is BrF3. Okay, we can draw the geometry as well so that we can come to know the correct options. BrF3 half. We'll use the same formula. 7 plus 3, 10. 10 divided by 2 is 5. Now 5 and how many lone pair? Lone pair is 5 minus, there are 3 side atoms. So there will be 2 lone pair. Okay, 1 lone pair like this, 2 lone pairs, Br, F, F and F. This is what? This is T shape. Okay, so the shape given is correct and we have drawn the correct product. Okay, this is X. Now BrF3, that is X, will undergo self-ionization. Okay, what we will get? BrF2 plus BrF4 minus. Okay, two molecules of this will react. Okay, let us first confirm disproportionation first. Here this is minus 1. More electronegative atom will get minus 1. Bromine and fluorine, which is more electronegative? Fluorine. Bromine and fluorine. So this will be plus 1. Br2 oxidation state will be 0 because it is neutral elemental state. Oxidation state of neutral elemental state is 0. This will be minus 3. This is plus 3. Now if you see plus 1 to 0, that is decrease in oxidation state. This is what? This is reduction. And plus 1 to plus 3. This is what? Increase in oxidation state, oxidation. Okay, so same element Br is undergoing reduction as well as oxidation. So that is, it is called disproportionation. Self-ionization, we have saw there is one cation that is formed. This is Y and this is Z. So what will be the geometry of Y? BrF2 plus, again the same formula, half into 7 plus 2 fluorine atoms minus 1 because it is a positive charge. 7 plus 2, 9, 9 minus 1, 8. 8 divided by 2 is 4. 4 means this will be tetrahedral. Okay, geometry will be tetrahedral, but shape, lone pair, how many lone pairs are present? 4 minus 2 side atoms. So 2 lone pairs. So what will be the geometry? Okay, geometry is tetrahedral. There are 2 lone pairs, okay, similar to water molecule. Okay, the shape will be what? It is bent. It is similar to water molecule. Then we have Z. Z is BrF4 minus. Okay, Z I can write here. Okay, Z will be BrF4 minus. This will be half into 7 plus 4, 11, 11 minus 1, 10. Okay, 7 plus 4, 11, 11 minus 1, 10. 10 divided by 2 is 5. So this is again a trigonal bipyramidal geometry. How many lone pair are present? Lone pair will be 5 minus 4 side atoms. So this will be 1. 5 steric number and 1 lone pair. This is going to be seesaw. Br, 1 lone pair, F, F, F and F. Shape is seesaw. Okay, now we can see the options. First option is X, Y, Z have same number of lone pair, count. X has 2 lone pair, Y is here, Y has 2 lone pair. Okay, Y has 2 lone pair and okay, let me check. This will be 7 plus 4, 11. 11 plus 1 is 12. I'm sorry, this will be different. This will not be seesaw. Okay, 7 plus 4, 11. 11 plus 1 is 12. Okay, so this will be 12 divided by 2, that is 6. 6 means this will be octahedral. Okay, octahedral, how many lone pair? 6 minus 4 side atoms, so 2 lone pair. So that is the reason why I told you that in octahedral, where is the lone pair occupying? Lone pair will occupy the axial position like this. And this is Br, and there are how many atoms? How many side atoms? Fluorine, 4. Okay, so the shape for this is what? It is square planar. Okay, lone pair. We were counting the lone pair. Here also there are 2 lone pairs. Okay, so all the 3 X, Y, Z have same number of lone pair, correct. Okay, Y has a bent shape. Okay, Y has a bent shape. What is, where is Y? Y, this is Y, right? This is X. Y has a bend shape, correct. Z is sp3 hybridized and has tetrahedral shape. Z is sp3 hybridized? No, it does not have tetrahedral. It has square planar shape. So third option is incorrect. X is used as a non-aqueous solvent. What is X? BRF3. Yes, BRF3 is used as a non-aqueous solvent. So the correct answers are option A, B, D. Okay, the options are missing. There will be one option where there are A, B, and D. That will be the correct answer. Now this question, okay, heat is given. Let us first draw the reactant that is given. 5-membered ring. Then there is 3-membered ring. 2 Br are attached. How this will take place? Okay, first step is Br minus will go away as a leaving group. Okay, what we will get? We will get a carbocation. Positive Br. Okay, so now what will happen is, the next step is there will be ring opening. How this ring will open? This will move here. Okay, so what we will get is, we will get a 6-membered ring. Okay, what do we get? Okay, let us number this. 1, 2, 3, 4, 5, and 6. Okay, 1, 2, 3, 4, 5, and 6. So 1, 2. Now this 1 and 3 bond is breaking, right? So there will be a positive charge at the first carbon. Positive charge here. Then second and third there is formation of a double bond. Okay, so here I will draw a pi bond. Second and third, and at the second carbon there is Br. Okay, this is the intermediate that will be formed. Lone pair, and then there is carbon having Br. Okay, lone pair, then carbon having Br? No, this is incorrect. We have 6-membered ring, positive charge, lone, then there is carbon having Br, then double bond. Okay, positive charge, carbon having Br, and then there is positive, then there is pi bond. So this is the correct answer. Okay, third option is the correct answer. Now what will happen? This is the lone, this is a carbocation that is formed. This will be attacked by Br minus. Okay, the same Br minus that had gone away as a leaving group will attack here. And what do we get is double bond Br, Br. So both the Br are at the adjacent carbons. You can see this. Okay, so the correct answer here is which option? Option 3. Okay, so here we come to the end of this part 1. We will see some more questions in the part 2. Thank you so much.